Okay, so now we continue with diving medicine, and now we'll talk about vision under the sea. Let's go under the water. Or vision in diving, it's better. This is the idea of this paragraph or area. Okay, so let's start. So we will start with principles of vision, and it will be general. So the idea of the eyes or the function is to convert what we convert light into, let's do like this, electrical signals. Yes, we convert the light to electrical signals that go throughout the optic nerve to the brain and to the occipital lobe. There we can interpret this signal to vision. Every sensory organ we have does that, take something and convert it to electrical signals. Okay, so let's start with the areas of the eye. So if we're looking in the anterior part of the eye, what we've got there, a, let's say, focusing. This is the idea. We have the cornea, we have the lens, both take the light ray and focus it into the retina. Yeah, if I try to describe you this, let's do it in paint maybe. So I have the light rays, they are right here, and I have the eye, and they take those light rays and focus it onto the retina to one place. Usually the most important place is the fovea, or which is the center of the macula. So let's think about the macula, okay? So here is the eye, it centers the light rays into the retina. Retina is the part that convert the light to electrical signals. Okay, so this is the idea of the anterior part of the eye to focus it. Now we have the cornea, which has a power of 40 diopter of focusing, and we can change it. And we have the lens that have a power of 25 diopter, and this one we can change. It helps us focus. So the cornea, which sits right over here, oh, let's do it bigger. This is the cornea, it's quite constant. But the lens that we've got here can change in shape. There are the ciliary muscles and everything here that can change the shape of the lens, which help us focus with from different distances the light rays that come to the eyeball, to the retina. Note that all this length of the eye is about, it depends on the person, but it is about 2.5 centimeters. So we don't have too much lens to make this. We need a very strong one that can convert those light rays into the retina. Okay. Now, as we age, the power of that we can do accommodation is weakening of the accommodation. This is the reason why people that gets old have harder time in focusing the light rays. So this is the anterior part. Now the posterior part is the most important part. In the posterior part is the retina maybe, which again converts light into chemicals, into chemical and then to electrical signals. Now, which cells do that idea? Those are the very important ones, the photoreceptor cells. We have two types of photoreceptors. One is called the rods, which are important for night vision. Let's call them night vision. And they're usually in the periphery of the retina. They are more numerous than the other type. There are about 125 millions of cells, and they can see less accurate vision. Now, the other type of cells we have in the retina are the cones, which and this is not color vision. The rods are not for color vision. Now, the cones are color vision, usually bright light, so it's daylight, right? Understand, not night vision. They are usually in the center of the retina, which is called the macula, and in the center of the macula there is the fovea, which is the place with the highest density of cones. In the fovea there are the maximum number of cones, and there are more accurate vision. This is our central vision. Now, there are much less than the rods. There are only 6.5 millions of cones. Okay, so those are the two types of photoreceptors. Now, the eye prefers some, let's call it wavelength. And there are wavelengths that more, let's say, up to the photoreceptors and make more effect on them. And another thing is important, that it's not just some of the light. Every about, I will drop a number, about 100 photoreceptors do complex analysis together to what they get and transmit to one neuron of the optic nerve. So it's not some complex integration, let's call it, of photoreceptors to one neuron cells in the optic nerve. Yes, so we are not just getting light and all the light from all the places just go to the brain throughout the electrical signals throughout the optic nerve. It's a complex integration of every bunch of photoreceptors that initiate the signals of a fiber of neuron. Okay? So again, only the cones can see color vision. And to evaluate vision, we have the Snellen test. This test, this is the maybe Snellen test. This is the test you probably know for eye vision. And the idea of the Snellen test is that for what let's say the patient can see, we compare it to a person that should see. Now, as you can see the right column here, if the patient can see those values from around 20, I don't know, feet or something. So if he sees those, I say the patient, go stand 20 feet from here and look at the Snellen board and tell me which line can you see. Probably you should say more than 50% of the letters of this line, so I can say that he can see this line. So if in this line he didn't see 50%, but in this one he did, so I say that his vision is this one. But if he was up to this line and here he saw 50% of the letters from 20 feet, so I say that his vision is 20 or 20. But here, if he got only to this place, so 20/70, because this is what a normal person sees from 70 feet, my patient sees from 20 feet. And this is the maximum vision capability of my patient. And this is how I define what is the vision capabilities of the patient using the Snellen test. Okay, now there is another test that can be done, which is the visual evoked potential. But this is a electrophysiological study and we won't get into it. Now, deep vision is another concept that we should know. And the idea of deep vision is that we need uh, two organs to feel something in order to have deep vision. I mean, if I want deep vision with my eyes, I need two eyes. If I want so this is one of the reasons we have two eyes to see the deep vision. Now, let's talk about what happens in the diving area. So in diving, what gets wrong? So there are two things that very gets wrong in diving. Remember that light is electromagnetic wave. It's a type of electromagnetic wave. There are photons and everything. It's an electromagnetic wave in certain wavelengths, but it's in the electromagnetic spectrum. Just certain range of electromagnetic wave is considered light. So there are two things that are important for electromagnetic waves to move in space. One is the absorption, and the other one is scattering. So the absorption of the light waves will be higher, and the scattering will be higher under the sea, for example. So we will have harder time to see things from distance, for example. And now, one of the very interesting things in light is that the low wavelength, which are the high frequency light wave, yes, those 47 nanometer light waves, which are the blue ones, those are absorbed less. This is one of the reasons why when you look at the sea, you look and see blue, because those waves are less probable to be absorbed. So if they are not absorbed, you can see them. So this is the reason the absorption and scattering is important, because this is the reason why we don't see very far in the sea, especially if it's not very clear sea. Now, let's talk about a disruption of the waves. What I mean by that, I mean that when waves go from one medium to the other one, they change angle. No angle. They move. They change their angle. So what happens if you have sea in one side and in the other side you have air? Where do you see it? Think about a diver. In one side there is the sea or water, and he has his glasses, and inside the glasses there is air. So in between, here the light should change direction. And if you look at the norm, here you have the air, let's call it A, and here you have the sea, let's call it S. And now the light wave comes like this, and then it breaks. Here, it breaks. Oh, this is less good. It breaks. And this says that we see, though this, if this one is the organ that we look at in the sea, this what the eye get, namely it sees a bigger organ, a bigger object. So the objects inside the sea looks bigger. I wish it was very clear, because the waves are scattered and see the organ like it came from here and here, so it looks bigger. The lights that come exactly in the focus are not changed, they don't change direction, so they stay in the same direction. But the light that come like this change direction. There is another thing that it is important. If the angle in which the light waves come is big enough, the light wave will only get back and won't get inside. Now, what angle is it? It should be more than 50 degrees, more than 50 degrees. Let's call it theta. Okay. So, oh, no, not good, not good. So, if my theta is bigger than 50 degrees, so the light, if here's the sea and here's the air inside the glasses of the diver, what will happen is that the light will go back and not get inside. And this is very important to remember. This means that the area that the diver can see is smaller, because every light wave from here the diver cannot see. Okay? So this concept is very important. So the object can be blurry, the object can be less accurate, because as you saw, the light waves go and change direction, so it's not very focused. But the diver can get used to it with practicing, so you will be better at accurately understanding the distance inside the water. Because if you take a new diver and tell him, please tell me, what is the distance in the water from this and this object? the diver will probably make mistake, and the mistake he will get in diving, mistaken distance, let's call it this. If the object, and it's important, if the object is close, so the diver will be mistake in thinking that the object is closer. If the object is far, and I will need to explain what is close and what is far, but if the object is far, it's exactly the opposite. The diver will be mistake in thinking that the object is far, let's see, more far than it is. More far than it is. And there is a border between them where the diver will be correct in estimating the distance. And this border is changing. It is not constant. It depends and it is not constant. Okay, and I think that this is it. We will stop right here. We talked a little bit, we started with the physiology of the important parts of the eye for vision. And we looked at the photoreceptors. Then we talked a little bit about what happens inside the water, the absorption, the scattering. Then we talked about how the wave changes direction in the sea when it goes from the sea to the inside of the glasses of the diver, what causes the object to look different. And the fact that evaluating distances inside the water for divers is harder. It depends if the object is close, so the diver will think it is closer than it is, or far, so the diver will think it's more far than it is. And there is a border that changes depends on how much the diver deepened inside, for example, the sea, the water. Okay, so this is very shortly about vision in diving. Thank you very much. If there are any mistakes or correction, please tell me, and that's it.